It's time for the most tricky case that we are going to work with, which is repeating quadratic factors. It's never a good sign when I purposely set it up to be 2 pages in the notes. It always means trouble. All right, so let's do step 1 really quickly. So step 1 is that the degree of the numerator, which is 3, is less than the degree of the denominator. We hope and pray. Yep. So this would be x squared squared, which is x to the 4th. X to the 4th times x would be 5. So x to the 5th. So yay. Woot. And we also notice that step 2 is already done, right? Denominator already factored. So double yay. Hooray. It's not a good sign. You still have 2 pages and I've already done 2 steps up in that corner. All right, so step 3. I'm going to rewrite this with repeated quadratic factors. So it's x cubed plus 10x squared plus 3x plus 36 over x minus 1 x squared plus 4 squared. Don't write the integral symbol. It's just not necessary. We're not worrying about integration until, to be honest with you, the next page. Okay, so we have all of that. It's equal to, now the linear term is easy. That's a over x minus 1. No problem. Plus, now I'm going to take x squared plus 4, like this, and I'm going to use bx plus c. Now, the book has it written b1x plus c1 and then b2x plus c2, but I'm going to just write dx plus e. I feel like working with capital letters. I think that'll be easier than trying to work with a whole bunch of subscripts. Again, if I was doing a really big problem, maybe I'd be limited in some way in that fashion, but all right, now I'm going to multiply everything by that common denominator of x minus 1, x squared plus 4 squared. Over here in this corner, we'll have x cubed plus 10x squared plus 3x plus 36 equals a times x squared plus 4 squared. Right? Because only the x minus 1 cancels on that term. Plus, and then a bx plus c times x minus 1 times x squared plus 4. Ooh. Plus a dx plus e, I'm running out of space, times an x minus 1. Whew. What a lot of work. And it's about to get worse. This is one case where I think method 2 will actually be better for us. So we actually want to take the time to multiply this out. However, there's one exception to that, and that's a. We could find a if we just let x equal 1. Because if we let x equals 1, this is method 1. But we're kind of limited in method 1, you'll see. So if I let x equal 1, then I'll get 1 plus 10 plus 3 plus 36 equals a times 1 plus 4 squared, because 1 squared is 1, right? Okay, so that's 5 squared, and this is 50. So 50 equals a times 25, right? So, because 5 squared is 25, so then a is 2. Done, right? So a is 2, wonderful, marvelous, fabulous, we've got it. Sorry, I'm going to underline that in pink, just to try to keep my color straight. But that's kind of the extent of it. Other numbers are just going to be atrocious in this. 0 is going to be awful. 0 doesn't lead us to anything good. We have variables all over the place. So this is a case where, honestly, we're better off with the second method in the long run. But I am going to stick to the caveat of a is equal to 2. I actually know that now, and I can actually substitute that in right there. And I'm going to. Okay, so let's do this. So we're going to do method 2 now. Method 2 says, and we haven't really done it, so let's take our time. There's the left-hand term, right? Just that piece. And then what I'm going to do is I'm going to distribute out all of these terms. So I know that a is 2, so this is equal to, and I'm just going to write this up. So this part right here, I'm going to FOIL out, and I'm going to put 2 in there for a. So it's 2 times x squared squared. So let me do a little bit of work on the side really quickly. So if x squared plus 4 squared is x squared, here, I'll just FOIL it, x to the 4th plus, right, because x squared squared is x to the 4th, and then outers and inners be 4x squared and 4x squared, so that's 8x squared plus 16, okay? And then I'm going to multiply everything by 2, okay? So that's what I'm doing right here. So it's 2x to the 4th plus, and then I'm going to put in a placeholder for x cubed, and I have my reasons. 0x cubed plus 16x squared plus 0x plus 32. There's that first bit all written out. All right, so now let's do the next bit. I'll do that in like this green color here. Okay, so the green part, if I take bx plus c and multiply it by x minus 1 times x squared plus 4. So let me write that out. That's bx plus c times, and then this FOILed out would be x cubed minus x squared plus 4x minus 4, like that. So it's really bx times all of those things, and then c times all of those things. So to be, and I'm going to write it out down here. So bx times x cubed is bx to the 4th. Bx times x squared would be minus bx cubed. Bx times 4x is plus 4bx squared. Bx times negative 4 is negative 4bx. See why I put the placeholders in now? It's so I can line everything up. So that's the b multiplied by everything. And then let me do the c in like a different color green, just so you guys can see it. So c would be cx cubed, so that's cx cubed, minus cx squared, plus 4cx, and then minus 4c, like that. All right, that was the hardest one, is that one. And then the last one is the dx and e. I'm running out of colors here. I'll do it in orange for this one. All right, so dx times x is dx squared. Dx times negative 1 is negative dx, right? So I'm doing dx times both of these things. So negative dx, and then ex, and then minus e, like that. I'm kind of doing dx times these two, and then I'm doing e times these two. Oh my goodness, what a mess. Yeah, well, except you know that the pairs have to work out, right? So if I look over here, you'll notice there's no x to the 4th term here. See it? So if I look at these two and I think about how I need to add them, I would think these two right here, 2 and b, have to make 0. There is no x to the 4th term. So let's look at the x to the 4th terms. 2 plus b has to be equal to 0. I just solved b. b is negative 2. We just figured it out. And keep in mind all along that we already know that a is 2. We already found that up here, right? Matter of fact, I'll probably highlight it. That'll be easier. Right, so once we get a number, we'll highlight it and give it a little star. Right, so there's A. A is found. We just found B. Done. All right, now let's look at the, and we can kind of go with whatever one you want. Let's look at the x cubed terms. Right, x cubed terms. I know negative b plus c. So negative b plus c has to be equal to, now go over to the other side, what's the number in front of your x cubed, right? Because these coefficients have to work out. So negative b plus c has got to be equal to 1. Ah, but I already know what b is. B is negative 2, right? So this is negative 2 plus c is equal to 1, right? So I'm using the fact that I know that b is negative 2 and I'm plugging it in over there. So that means that 2 plus c is equal to 1, that means that c is equal to negative 1. I got another one. Now let's look at the constant terms for a second. Let's look at the whole numbers. 32, negative 4c. But I already know what c is. C is negative 1. And then 36 over here. So let's look at the constants. I'm avoiding right now the ones in the middle with all those letters in them. I'm kind of holding back on those for a second because there's so many of them. All right, so 36 is equal to, because 36 is over here, 32 minus 4c but I know what c is, so I'm going to use it in a second, and then minus e. See right there? So the constant terms have to work out. Right, these numbers right here, they've got to work out, right? Well, I guess I could circle around the letters. There they are. They've all got to work. Okay, so then I know what c is, so I can use that. I can also bring the 32 over. So that's 4 equals negative 4 times c, which was negative 1, minus e. So this is 4. So 4 equals 4 minus e, so e is equal to 0, right? Because you subtract 4 and you're going to have 0. There's another one. We have a, b, c, and e. All we're missing is d. Okay, for d, you can either go to the x term or the x squared term. It kind of doesn't make any difference, but it's the last one you need. Keep in mind, if you look here, you know b, you know c. The only one you're missing is d. Right? Same thing here. You know B, C, and E, but you don't know D. So either one of these will work. You don't need to do them both. You just pick one. So I'll choose the x squareds. I'll go this way, right? So if I look at the x squareds, over on the left, I'll have 10, right? So that coefficient 10 has to be equal to 16, take away, or no, plus, sorry, that's a plus in there, plus 4 times b minus c plus d, right? 16, take away, or plus 4b, sorry, that's a plus 4b minus c plus d. Okay, well, I know what c and b are. I can use them, right? So c is negative 1, b is negative 2. So I'm going to plug them in down here, right? I'm substituting, right? Actually, I'm substituting in right there, right, for that one, if you want to see it. Okay, so, and I'm going to bring the 16 over. I might as well. So it'll be negative 6 equals 4 times negative 2 plus negative 1. Actually, wasn't that a minus c? Oh, it was. Whoops. That was a minus c. Hold on. Minus c. So it'll be minus negative 1, like that. So minus negative 1 plus d. And then it's just a question of finding d. Oops, I grabbed the wrong pen. Plus d. So then that's negative 8 plus 1. So this is negative 6 equals negative 8 plus 1, which is negative 7, plus d. So d is 1. I have all my letters. Amazing, isn't it? Whew, all of that. All of that is just to get those letters. And again, this method could have been used for all of our problems. I just generally don't bother with it unless I have to. In this problem, substituting lots of values wasn't really going to be very effective for us. It was going to leave us with a mess no matter which way we went. So I decided to use method 2. So I use method 1 right here to find A. That was pretty straightforward, just using 1. And then I'm using method 2, right? So from this point on, it's method 2. Right? I distributed this all out, and then I'm using the fact that the x to the 4th terms have to add up to what the x to the 4th term is here. The x to the 3rd terms have to add up to the x to the 3rd terms here. The constants have to make 36, and so on. And I'm kind of avoiding well, I avoided the linear term because it had the most letters in it. So I chose the other ones instead. All right, now I haven't actually done any of the calculus yet, right? So all of this is step 5, all of it, even up to here. It's even higher, right? All of it is step 5. From finding that A value, finding the B values, method 1, method 2, writing it all out. That is all step 5, the whole page. So now I actually have to write it out as an integral and do step 6. But the calculus is actually the easy part about this problem. So because now that I know this works. So step 6, rewriting the integral. So the integral was given to us as x cubed plus 10x squared plus 3x plus 36 over x minus 1, x squared plus 4 squared. We now know that we can rewrite that as the integral of a, which was 2, over x minus 1 dx plus, and I'm just assuming I'm going to have to break up these integrals. Maybe I'm wrong, but I figured with quadratics, it's pretty safe bet that everything's going to work differently. So it was x squared plus 4 for the middle term. And then it was, let's see, 2x plus 1, right? So b was, oh, it's minus. So it's minus 2x minus 1. So I could say plus a negative 2x, negative 2x minus 1. So there's b and there's c dx plus one more integral. And then it was over x squared plus 4 squared dx. And this will be the d and the e. So that was 1x, right? It's 1x plus 0, actually, because the 0 canceled out. So, or the e canceled out. So it ended up being like that. So I'm kind of doing step 5 and 6 together because I'm rewriting it and then I'm going to integrate it. So this is step 6. I take that back. So it's writing all the integrals out. You don't have to separate them, but you're going to need to in a bit anyway because each of these 3 integrals gets worked in its own way. So now it's on to the calculus. So this one we'll rewrite as 2 integral of 1 over x minus 1 dx. And we know how that's going to work. That's going to be a natural logarithm. No problem. All right, next one. So it's going to be minus 2 integral of x over x squared plus 4 dx. So that one's going to take u substitution. And then minus 1 integral of 1 over x squared plus 4 dx. That's the arctangent. That's going to be number 19 with the arctangent formula. So we'll be back for that. And then plus integral x over x squared plus 4 squared. There's not much to do on that one to make it easier. Okay, 2 of them need u substitution. This one right here. So u would be x squared plus 4. Du would be 2x dx. So then if I have a half du is equal to dx, that'll be great. I'll be able to substitute. Things will be grand. All right, then over here, u is also x squared plus 4. Du is still 2x dx. It's the same substitution, right? It's just being applied in slightly different problems here. Oh, did I lose my x? I did. Over here. I have to use x dx. There we go. Okay, so then it's up to you. I mean, if you want to keep writing this as an integral or if you actually want to do the integration. You know what? I'll keep writing it as an integral until I'm ready to do all my integrals at once here. So then this one is minus 2, then there's a half, and then integral of 1 over u du for this one. Right, so I have my half du, 1 over u, then minus 1 integral of 1 over x squared plus 4. And I can tell right away, by the way, that a squared is 4, so a is 2. So if I'm looking at rule number 19, which I will be, right, I know that what that one's going to be, right? It's the arctangent one. Oop, don't forget your dx. So these two are x's, these two are going to be u's. And then again, this is the integral of 1 over u squared du. Oop, du. And I'm going to need a half in there, right? So a half and then a du, like that. This would be the same thing as u to the negative 2, by the way, right? Which is how we actually integrate it, right? We don't deal with fractions like that. We make them into powers. Okay, so time to integrate. Now, technically, we could have integrated a couple of these already, but I figured let's hold off and do it all together. So 2 natural log absolute value of x minus 1. That's that one. No problem. Minus, oh, and then here, the 2 and the half are going to cancel. So it's just going to be minus. And then the natural log of the absolute value of u. All right, then this one will be minus 1 over 2 arctangent of x over 2. It's that formula, number 19 on our quick sheet. And then this will be plus a half. Oh, it'll be minus a half, won't it? Because when we add 1 to the power, it'll be negative 1. So I take it back. Negative 1, and then you multiply. So it'll be minus 1/2 u to the negative 1. Right, because this is 1/2 du, like that, right? Okay, so, oh, and then plus c, because we've done all of our integration, so there we have it, plus c. And then I'm just going to go back and put what things were. So this is 2 natural log absolute value of x minus 1 minus the natural log absolute value u was x squared plus 4 minus 1/2 arctangent of x over 2. And then this will be minus 1 over 2 times x squared plus 4. Is it negative 1 power means it's in the denominator, plus c.